probability for higher marks and plenty higher probability for center marks because average is 62.
Sir, each dot represents the marks of students, no?
Yes.
Okay, sir. Thank you.
See the graph?
Sir, is the 12 standard deviation
Yes.
of the...
Yes. 12 is the standard deviation of the marks of 1000 students. 62 is the average marks of the 1000 students. And all these students are within the graph, green graph which I have drawn. How many students are above 62?
50%?
Correct. How many students are below 62?
50%.
So I say the marks are normally distributed graph. Now, I am going to generate many samples of 20. Now the syntax will be, I am going to select 500 samples, plural. Each sample has 20 students. So the algorithm is ITER, means iteration. ITER means iteration 500 times. Each sample size 20, n is 20. And the loop, arithmetic mean will be finding each time. So represent, repeat, REP, repeat arithmetic mean in ITER is the syntax. NA means nothing other than arithmetic mean. Clear?
Yes, sir.
ITER's variable is process 500 times, each time 20 students, compute arithmetic mean other than nothing in each iteration. So NA means not available other than arithmetic mean. Loop for syntax I in 1 to ITER. That means 1 to 500.
Sir,
Yes.
could you please repeat this whole
Yes.
loop process?
Yes. Loop starts now for computation and selection. Selection and computation. Loop says I. I means 1, 2, 3, 4, 5, 6, 7, 8 up to 500. And each time find out a sample D of 20 students. Compute arithmetic mean of this sample. Repeat it. Is that clear?
Sir, I did not get what the NA stands for.
Sample size 20 students from 1000 students.
But sir, that you have written NA, whereas the variable assigned is just N, and that too is lowercase and uppercase.
Already I have given 20. See,
I think NA represent not a...
it is already given. N is 20. See,
Yeah, sir, but then what is the NA? Wherein you said that
sample
is not
size.
available.
Sample size. N is sample size. Each time select 20 students. Are you getting now?
Sir, what is ITR? Can you explain,
No.
sir?
Iteration. A repeated process.
Sir,
Okay, sir.
you have mentioned N to be 20, right? And then
Yes.
you are saying that this NA represents this N. Is it right?
AM.
No. N represents NA, right?
Yes.
So then how this value would be considered in the syntax? Because like they are two
Because
different
already we
notations.
have assigned na variable n is 20. It will take.
But
Sir, what is NA?
Yeah. NA.
sir, the third
Sir,
line,
NA
third
See the
is
line.
a
question paper. Let me see.
non-availability,
Let me
I
share
guess.
the question paper first. Let me share the question paper. NA. NA means not applicable. No other matter. No other computation. No other statistics. Only arithmetic mean. That is the meaning.
Okay, sir, got it. So the first argument is basically we are asking just to compute mean and nothing else.
Nothing else. Barabar. That's all. That's all. That's all. Good. That's all. So capital NA stands for nothing other than arithmetic mean. In case if I ask something else, I can do that. Later on, we will see. Let us see now only arithmetic mean. So repeat.
Sir, but still I have a question.
Yes.
Like, when we are writing this loop, for, like, we are giving a loop wherein, like, we are saying that we need, we are mentioning mean, like, in the fifth line where it is saying that AM1 and it is saying find mean for me from this syntax, right?
Yes,
That
yes.
is what it is trying to do. So, like,
Yeah.
if we are passing this syntax, why do we even need to mention that if we need something else or not? Because if we are telling the machine to compute mean, would it not just give mean?
Yeah. Yeah.
So then what's the reference for this NA?
I will tell you. If I simply write mean, it will compute for that data only. But here is a repeater process, na?
So,
I
sir,
have written mean.
for that, we are giving this iteration. Now, in the second argument, the iteration is taking consideration of the fact that it has to take 500 times this particular function. So, it
Yes.
would be computing. So, then what's the reference for this NA? That is what we are not understanding.
Yes, that is what I say. NA means not available other parameters. Only use iterations to compute arithmetic mean. That's all.
Okay.
Nothing other than arithmetic mean is the verbal meaning. Repeat, repeat. REPC, REP.
No, but sir, what would
REP
be the
means
impact? So what would be
repeat the process, and in the repeated process, compute arithmetic mean only.
Okay, so what would be the impact of not mentioning this NA, or what other things can be mentioned here?
Yes. Suppose, see what happened. Suppose if I delete it. Okay. Suppose I delete it. Okay. Now I say go for algorithm. Let us see whether we can get it or not. I am repeating now the graph of all the 500 arithmetic means. Got it. You can avoid that NA also if you wish. Okay.
So, it's not relevant. Like, we
No.
can avoid it,
No.
right? Okay. Sir.
No, but the verbal meaning is full will be computed. Arithmetic mean for every iteration, nothing other than parameters. Okay? Happy now?
Yes, sir.
So this is the graph I am getting. So what is the meaning of the graph? How many samples are within the graph?
500 samples.
500 samples. Well, how many arithmetic means are there in the graph?
500.
500.
Sir, would it not be-
Each one is of how many students?
50 samples,
20.
right? So 50
Yes.
samples, right? Not 500.
Huh?
So 20 of each, no, so 50.
50?
So 50
Sample is of 20.
So what we have done now is
there will
we
be
have
50 samples.
created. So what we've done now is we've created 500 samples of 20 each, right?
Yes. And uska
Okay.
arithmetic mean is plotted.
And the
Okay, sir.
average of every sample would be the same as it would still be 62. The average of each of those 500 samples.
Average, yes, 62. 62.
Okay,
Sir,
哦 sir. ，
like on the same lines, I would want to ask why would it be 62?
，
Why would it be 62? if if it is 62 for each sample, then why did we need
No. For each sample
Not for-
cannot
it
be
would be, it
62.
would be different for every sample,
It will
right?
be
Because we are
different from
taking different
sample to
values.
sample.
Sorry?
It will be differ from sample to sample.
But sir,
Okay,
the
sir.
average
Right.
of the averages will
But
be
the graph
62.
is histogram. Wait. The graph is histogram.
So sir, the
Graph of all the samples, all the 500 samples behave like a histogram shown here.
Yes, sir. Basically, we are
Many
plotting
of the
mean.
samples are near the average 62, and many of few samples are away from 62 to the left, away from mean to the right.
Okay, now sir, my question is, would the average of each of these averages be 62?
No, each word you cannot use.
No. The average of all the averages.
Average of all the averages is 62. That I'm going to prove.
Okay, sir.
It is not over.
Okay.
It is not
Thank you,
over.
sir.
See now what's going to happen. Okay, up to this graph clear?
Yes, sir.
Up to this graph is clear.
Sir, I have a doubt.
Ask.
What is D here?
D means the data.
Okay,
Like a
sir.
variable. I can type the DA, I can type their Y, I can type their U, I can type the W. Sample data. D stands for data generated by the sample from the population data of 20 students. Is the English. Then see AMI. Compute the arithmetic mean. Repeat it 500 times and plot a histogram. So the histogram consists of 500 arithmetic mean. Now let us compute something. How many are in the histogram? 500. I have given the title next, arithmetic mean of all the 500 sample means. Usual way, compute the mean of AM, plot it. How much is the mean?
61.70.
That I am getting. And actual population mean how much?
62.
62.
And 62 and 61.7 ka difference point,
Point
Three.
two.
which means approximately the histogram also behave like the original data.
Yes, sir.
Yes, sir.
There marks is on x-axis, here the sample mean is on the x-axis. So all the 500 samples are behaving like your original data. Oh, not over. This is what by sample mean, and this is what by mean 61.7 something, green color. And standard deviation of 500 sample means also I can compute as usual. Standard deviation comes out to be 2.86. And this standard deviation is called standard error. This is not the standard deviation like original data. Original data is individual value, but this standard deviation is individual sample mean. That is, each sample mean deviate from 61.7 how much?
So please
And this-
repeat.
Yes. In original data, 62 is the arithmetic mean of marks of the student. Marks. It is not sample. Marks. And 12 is the standard deviation of mark. But here, 61.7 is the mean of all the sample means. And each sample mean deviate from 61.7 by 2.86. And this has a formula. And that formula is given by sigma. Sigma means original number. Your 12 divided by square root of n. That is the formula for standard error. How much it comes? How much it comes?
Sir, it's different from what we got earlier.
Yes, but how much the answer? 2.68.
6.8, sir.
6.8.
And earlier I got 2.86. So the theoretically 2.68 is the permanent standard error for sample mean from 62.
So I have a question.
Yes.
Does it mean that if we would be passing 1000 iterations, still this would be 2.68 only?
Very good. You can do it. That is what central limit theorem. Increase your sample size. Your sample mean will be going near to 62 with a smaller standard error.
Okay, now, sir, one
Meaning-
more question.
Yes.
So, what is the practical application of this? As in, where is this used in real life?
Yes. For that, you have to wait for the next class or the end of the class today. Testing of hypothesis is completely based on central limit theorem. It has a wonderful practical use. My attempt is to make you understand testing of hypothesis. Some introduction I am giving at the end of the class. Let us complete first the central limit theorem to show some patience, okay?
Sure, sir. Thank you.
So, the complete thing I will draw on the graph. See now the graph. Complete work I can show on the graph. Finished. This graph and the earlier graph will be the same, but point of symmetricity there it is 62 and here it is 61.7, correct now?
Yes, sir, it skews slightly towards the right.
Approximately equal to 62, but each sample deviate from this mean by how much?
2.68, sir.
Perfect. That is called standard error. You learn in regression analysis. In regression analysis, what is the meaning of standard error of forecasting? Come on. In regression analysis, what is the meaning of standard error of estimation?
So it means that how much the points deviate from the straight line.
Correct. How much deviation of the data from the
Straight line.
same concept here also? How much the sample deviate from 62? Standard error 2.68. Same concept. There we talk regression line. Here we talk 62 population mean. There we talk about individual value of the data. Here we talk about the sample mean. So this demonstration says, this is the conclusion. Probability distribution of sample mean is a normal distribution with mu and standard error is the conclusion called central limit theorem. This is the conclusion for section A.
Sir, is it, I'm not sure, but is it Monte Carlo estimation?
Yes.
Okay, sir.
Simulation and doing the work. Monte Carlo method is
sir,
simulation for
again-
any distribution.
There is a limitation to it, no? That like beyond standard error, irrespective how much we increase our n,
Yes.
it will.
Very good. Very good. So we have to increase the n to reach a better model.
No, but sir, would the standard error go down as we?
Yes, definitely. As increase your sample size, standard error will be less. That means increase the sample size, your analysis approaches to your objective of the research.
Is there a possibility of overestimation if we like?
Or if there are outliers,
Okay.
if the data consists of unwanted observation, they will disturb you.
So how do we know which is the
For
optimum?
that, you have to
end?
know graph of our data first. Unless you draw the graph of your original data, you cannot find outliers, like in correlation regression also.
No, sir, outliers I understand, like how we can actually know the outliers. I'm
Yeah.
asking, like, what is the optimal value of the iterations that we do to
Yes.
minimize the risk?
Yes, that will be determine the sample size to reduce the error. How much sample size shall I take to reduce the error? That is a part only after center limit theorem I can tell you.
Okay, sir.
Okay, very good. Very good. So, this is for the conclusion. Probability distribution of sample mean is normally distributed with the parameter mu and standard error as the standard deviation. Here we not call standard deviation. Here we call standard error. That is what my last graph shows. I'm going to repeat the section A. This is the way shape of the graph it shows. Repeat my work.
Sir,
Yes.
so I'm understanding the concept which you are trying to make us understand, but from the iteration part, I'm not getting algorithms much. Could you please explain it step by
Yes.
step?
Yes, I will do.
Thank you so much.
I will do. I will do. Consider a normal population of 1,000 students appearing for a test of 100 marks each. So this original data has only 1,000 observation. That is nothing to do with the sample. That is nothing to do with the sample. But these 1,000 student marks has average 62, standard deviation 12. Which means I'm going to draw a graph of the data. I select 1,000 students and I plot a graph. I find out a probability data. I will plot it and then average also I will plot, like our module 4. This is original data. 50% students got marks below 62. Another 50% student got marks above 62. Now, central limit theorem. Central limit theorem says if you select the samples, plural, each of size n, so in this case, 500 times I am going to select the sample. Each of the sample is 20 students. Compute arithmetic mean are the variables. Who asked me the last? Is it clear now? Variable introduction.
Yes, sir.
How many times I am going to find arithmetic mean?
500 times, sir.
Each time how many students I am choosing?
20.
20.
So how many arithmetic mean I have to compute?
500.
500. That is called repeat the iteration. Loop. For I1 to ITER, minimum value of I will be 1 and the maximum value will be 500. For what? Curly bracket, select 20 students compute arithmetic mean, and loop will go on computing 500 times and plotting a histogram. Clear the loop now?
So one question.
Yes.
If suppose we increase the ITER to suppose 600 or we reduce the sample to 18 or something, our results would still more or less be within 2.68 or something, right? Standard deviation.
Yes, because
More
we
or
are
less.
generating samples, na?
Okay. Cool.
Okay. So, in this loop, I will be having now 500 times the loop will work. And finally, I will plot my histogram for arithmetic mean. But I can plot a curve. I can plot a curve. I will compute the mean of all the 500 means. Then if I plot, let us see what I get. Still remain symmetric. I will compute the standard error sigma by root n. And I will plot the complete thing on a graph. What is the meaning? Original data is normal, sample mean also normal. Original data symmetric at 62, sample distribution also symmetric at 62 approximately. Original data standard deviation 12. Here the standard deviation is 2.68, but we call standard error because we are computing the sample mean deviate from the population mean by how much? This is what I said, central limit theorem. This is what central limit theorem. Rahul Giri,
Yes, sir.
do you follow? Sincerely tell me the central limit theorem section A.
All right, sir. So, sir, in central limit theorem, basically, we took this example wherein we computed the mean of a class, which was found to be 62, and then we had a standard deviation of 12 for that particular class. Then what we did, we took 500 iteration for the same sample, and we computed mean
From same population.
from the same population, and then we computed average for mean for each of these samples.
Yes.
And then we found out that the standard the mean is approximately similar to what we observed for the population.
Yes.
With a very minute difference, and we calculated this difference, which is known as standard error, by taking the standard deviation divided by the n. So that is how we got the standard error for these observations.
Sample mean.
So what we are trying to say is that as we are increasing the n, what we are getting closer and closer to the population. So this is what central limit theorem tells us.
Very good. Very, very, very good.
Thank you, sir.
Chitwan Garga,
Yes, sir.
do you follow clearly the work I have shown?
Yes, sir.
No doubt?
No, sir.
Okay. Anybody want to ask anything?
Sir,
Yes.
sir, my syntax of for loop is not working. That curly bracket is showing error.
Oh, that you verify again later on.
Okay.
Carefully handle the syntax. Okay. Already they are there in your question paper. Check it later. Fine. But you understood the work?
Yes, sir.
Next question.
Sir, when we are finding the optimum n, what we are trying to say is that we can actually minimize the standard error close to
Yes.
0.
By increasing the sample size.
Correct. So, but does it not mean that we are replicating the population, which is impossible?
No. How much more information you collect, that much better will be your analysis. More and more information.
Yes, sir. But like to certain extent, it will tend to 0, right?
Yes. But we cannot make 0. If you want to make 0, you have to consider all the data. Is it
No,
possible?
sir. But when I ask you this question, that what is the optimum number of iterations that we need to? So, if we
Optimum
can find
number.
that n,
We can find Giri. Optimum number is based on how much tolerable error you can have. Fix an error, determine the sample size. So when you analyze it, your error will never be more than the predetermined error.
okay, sir.
I will show you.
Okay, sir.
You have to fix the standard error, how much error you can tolerate. Suppose you are appearing for an examination and you saw that paper is of 100 marks and possibly I may not get 100 marks, but generally you may be knowing some error. Your marks may be little above 90 or little below 90. Your expectation is 90, but actual marks you are getting maybe more than 90 or less than 90. So the difference is called error. Isn't it?
Yes, sir. Yes, sir. Got it.
Same way, prefix an error in your analysis and then go for sampling. Your analysis will have an error never beyond the fixed error. That is called level of significance in testing of hypothesis.
Sir, this is a very constrained example wherein we are just taking few observations and there is only single variable.
Yeah.
However, when there would be new variables introduced to the model,
Oh,
so that fixing of standard error.
Multivariate study.
Okay. But can we still fix the error in that situation, by calculating the, how do we do? Would we learn this? Would we learn that in the
That is what the statistics is. You are just learning the elementary work. And this has to generalize for more than one variable.
Okay, sir.
Multivariate study. You see? If you have a research attitude, you cannot stop after this course. You have to go for learning higher level statistics. More than one variable. Isn't it in correlation regression 2 variable? Can't we have more than 2 variable in correlation regression?
Yes, sir.
Same way.
No, sir, that's what I'm trying to ask. If there is a disturbance, that's what, there is a new disturbance entering. So if we have prefixed, as you suggested, if we are prefixing a standard error and to that particular level, we can, reach closer to the population. But, certain shocks would always be undetermined. They can just come in. So,
Yes.
So for that particular thing, how do we deal? That's what I'm trying.
We will continue that later, Giri. Okay?
Okay, sir.
Okay. So here, any other question based on my demonstration? Do you follow section here, Shubham?
Yes, sir. I follow everything, sir.
Okay, Mihir.
Sir, I follow. After the diagram, everything is clear, sir.
Yeah. Now, let us go. Anybody has another question? I'm going very slow today. Still, I have lot of time. Lot of time is there to complete center length image. Nothing, no doubt should keep in the mind. Repeat again. Whatever I demonstrated was my original data is normal with mean mu and standard deviation sigma. My generated sample mean data also normal with mean mu but standard error. This is the meaning I said. This is what I said. Shape of the graph, both the case is normal. That is the language used in your handout, shape. Shape of both the graph is normal. Now I am going to section B. Now I am going to section B. In section B, original data is not normal. Sampling distribution of non-normal distribution. That means original data not behave like a normal graph. And for that, we have already familiar about the tree data. In correlation regression, we have taken a data of file trees. I took the data from tree file. This is what my original data. How many observations I have for the variable?
31.
31. How many students we had in earlier class, any earlier section?
1000.
1000. What was the variable there?
Marks.
Here the variable is
Girth, sir.
first class. I will compute the average of this and standard deviation sigma. How much is the average of 31 trees?
13.24.
How much was the average in the earlier section?
62.
How much is the standard deviation now?
So it's 3.138139.
How much was there?
Sir, 2.68 something.
No. Standard
2.86.
deviation.
2.86.
No.
2.860, sir.
Oh,
पहले
0.7.
No.
12.
12.
Acha, oh,
Sorry.
standard deviation. Yes, sir. 12.
Original data.
Original, yes, sir, 12, sir.
So this data is parallel to that, but the graph is not normal. Why? Let us see. See the graph which I plot histogram. Is it normal graph?
No, sir.
No. So here my original data is not normally distributed. Here my data is not normally distributed. Now I am going to do samples. Repeat the loop 25 trees, 300 times, compute arithmetic mean, plot the histogram. What happened to the histogram of sample mean?
It changed.
Normal.
It behaved like
Normal distribution.
normal distribution. It behaved like normal distribution. Draw the normal graph of it. I'm repeating all the earlier work. Nothing new. Nothing new. Data different. What is the meaning of the final result?
So irrespective of our original population, if we will be increasing our n, then we will always observe normal.
Yes, irrespective of the original data, sample mean distribution is always ALWAYS, always normal with parameter mu and standard error is the central limit theorem.
So just
I have written here, probability distribution of sample mean is normally distributed with mu and standard error is the conclusion irrespective of what is the original population data. What is the original population data?
Sir, I have a question.
Ask.
Does sample size of of the data determines what do you say, like if it will behave normal or not, or is it just the iterations that we take?
No. Normal sample size. Larger
So-
sample size, better will be the normal assumption.
So, like, in the previous case, we just took a sample of 20 in each
Yes.
like class,
Yes.
right?
Yes.
Wherein, like, in the, but still we still observed a normal graph for that
Yes,
particular
yes,
also.
yes, yes.
And
Because
in
that
this case,
in n equal to 20, originally it's normal, so it also become normal only.
acha, okay. So that's the catch.
In the section A, original data itself is normal. So from normal data, if you take the sample, it also behave like normal.
Because in the second example, we just had 31 values and we took a sample of 25. So more or less, we're
25. Yes, increase the sample size.
okay, sir.
That is the reason, say, irrespective of shape of the distribution, as large as your sample size, sampling distribution is normal with mean mu and standard error. Let me go back to your question paper. Let me go back to your question paper. Yes. Now see the yellow background. CLT is sampling distribution of the sample means approaches to normal distribution as the sample size gets larger, no matter what is the shape of the data distribution. Here's my demonstration section A and B. In our section A, original data is normal, sampling distribution also normal. In section B, original data is not normal, but sampling distribution is normal. This is central limit theorem. And exclusively, sample size is larger and larger, your sampling distribution become normal with smaller standard error. Red line now. An essential component of the central limit theorem is average of sample means will be the population mean, 62 and 61 point something very near. Next, 13 point something with some average, they are near. Similarly, if you find the average of all standard deviations in your sample, you will find the actual standard deviation of your population called standard error. And this is the work I have done. Look now. Mean of samples is same as the mean of the population. Our mu x is equal to 62, original work. The standard deviation of the samples is equal to standard deviation of the samples is equal to standard deviation of the original. This is for original data, but the central limit theorem is applicable for sufficiently larger sample size, theoretically n greater than or equal to 30. The formula for central limit theorem can be stated as average of the sample means is same as population mean standard deviation of the sample mean is same as sigma x by root n, which we call standard error. Y bar. Y bar stand for sample mean. X stand for original data. So mu x stand for population mean, sigma x stand for population standard deviation, mean of y bar stand for sample mean, sigma y bar stand for standard error, and is the sample size. An example also shown. The record of weight of the male population follow normal distribution. Its mean is 70, standard deviation 15. If a researcher considers the record of 50 males out of it, then what would be the mean and standard deviation of the sample? So mu x 70, standard deviation 15 given, n equal to 50. Mean of the sample is y bar and standard error will be sigma by root n. If I select a sample of 50 students, the deviation sample mean and 70 will be not more than 2.1 kg is the answer. All of you go through the example. See the example. All of you, read carefully the question, see the solution shown below. Is it this question same as our section A?
Yes, sir. It is quite similar.
Yes. There the variable is marks, here it is weight. There we have 1000, here we don't know how many. Here we have given average 70, standard deviation 15. Sample size there 20, here 50. Arithmetic mean is y bar and question is only for standard deviation. And standard deviation is sigma by root n, 15 by root 50. That comes out to be 2.122. The meaning, if I choose 50 males, their average weight will deviate from 70, not more than 2.1 kg. Either left of 70 or right of 70. Any other question, anybody? Giri?
No, sir, it's clear.
Yes. Anybody else? Today, not problem, only discussion. Okay. Before I go to the next work, attentive. Somebody asked me what is the practical use of this. Somebody asked me, sir, what is the optimum value of n? So that I am going to incorporate with the testing of hypothesis in the Thursday class. Mainly, how many samples shall I choose, sir, for a better result? But before I go for that, let me tell you something more. After repeating all the work again by the graph, algorithms everybody has on the question paper. So let me go to share with you again my R. I started with normal distribution graph. Original data mean 1062, standard deviation 12. In the example, weight will be the value, weight will be the variable. Here it is the marks. Here the average 62, there average 70. Here the average 12, there the average is 15. I repeated selection of 20 students 500 times and I computed the arithmetic mean 500 times and plotted a graph for the complete 500. Both the graphs same. Mean also approximately same here. And their standard deviation we called, here we call standard error.
Sir,
Yes.
can we choose the number of iterations and n differently? Like you have taken 500 and n as 20.
You can take any number. देख लो, suppose I take 30. See, instead of 20, I will take 30.
And what about iterations? How have you chosen a number of iterations?
Say 600. Okay.
Okay.
Now see the work. See the work. Again, let me get to select from beginning. Iteration 600 and 30 will be the sample size. Yes. See the graph again. Is it a standard error reduced? Isn't it standard error reduced?
Yes, sir.
And whenever original data is normal, any sample size if you take, that will behave like normal only. In section B, it is the other case. In section B, the original data is not normal. But sample data, sampling distribution is normal. See, this is what I demonstrated. This is for the yellow. Shall I continue? This is what I have demonstrated. Vrishalia here.
Yes, sir.
Do you follow section A and B that I have said about central limit theorem?
Yes, sir. I mean,
Well,
80% plus. Sorry, sir?
Very well.
Yes, sir. Almost, sir.
But if not understood, after my class, think again and ask next time.
Yes, sir. Sure.
Stuti Mehrotra,
Yes, sir.
do you follow section A and B?
Yes, sir. A better than B. So, did the B section conclude that the more n we take, the standard error reduces? Is that
Yes. Yes. Yes.
the okay?
Yes. Chitvan Garga,
Yes, sir.
Any doubt?
No, sir.
Well clear?
Yes, sir. Yes, sir.
Mohit Mishra.
Yes, sir.
What is the difference between section A and section B demonstration?
In section A, you taught us that how a normal distribution curve, like normal distribution, and basic difference was in section A it was a normal distribution, and in section B it was non-normal distribution.
But what is the conclusion in section A and section B? Are they same?
Yes, sir. Like probability distribution of sample mean is like normal distribution.
Very good.
For both.
Yes. Good. Very good. Saloni Kejriwal.
Yes, sir.
Any doubt on section A and section B?
No, sir. Not now.
Okay. Good. Now for the remaining time, before question answer session, little higher level, I am discussing the remaining part today.
Sir,
Yes.
one more doubt. I guess someone has asked this earlier as well. Like, if we are given the research work in our real life, then how will we supposed to take the sample size? Like, how will we get?
Yes, Himani Gaba, very good question. You wait for few more day, okay?
Okay, sir.
Just wait for one day. Thursday I will tell you. At present, if I say it will confuse us.
Okay, sir.
I will keep in my mind, I will explain the answer. And to reach such stage, let me start a discussion with all of you. Yes, Himani?
Okay, sir.
Yeah. So, attentive. Many good questions came today. I keep all the questions in my mind and Thursday it will get clear. Now, Priyanka Bokil. Though I am asking the question to Priyanka Bokil, it will be for everybody. Priyanka Bokil. Not reaching. Yes, I will ask Rahul Giri. Let us see how he will answer. Rahul Giri,
Yes, sir.
tell me, what is the probability that I will be taking your class on Thursday?
Sir, 100%.
It would be certain.
Correct. 100%. Why?
Sir, based on the previous patterns that we have observed, that you have never missed a class. So on.
But still it is 100% sure?
Sir, it's certain, but yes, there could be some emergency because of which, like, you
No,
might not.
what will be logically answer?
Logically, yes, sir, it would be 100%.
100%. Okay. So Rahul Giri says, probability that I will be taking your class on Thursday is 1.
So shouldn't we say it should be near to 1, like if we consider some emergency case or something?
Right. Himani says near to 1. Any other answer?
Sir, it could be lower as well because it's New Year's Eve, so you could have plans also.
Lower
We
मतलब
would have
कितना
loved
lower?
that just in case. It,
Lower मतलब कितना?
Approaching 1.
Okay. Any other answer? Any other answer? Oh, nobody responding properly.
Sir, approaching one only from my side also.
Yes, approximately one. Approximately one. These answers everybody gave is correct. Can you modify the answer in terms of some error word? Standard error or forecasting error or simply error term. Using an error term, can you modify the statement?
So as our number of classes with you are increasing, we are realizing that you don't miss classes. So the standard error keeps on falling.
Correct. Perfect. Perfect. Even if Giri said that my approach to the class on Thursday is 1 and that is for the future class, and that also he says by past experience, so he would have said, even if I never missed your class, there is a small error of probability to be 1. Simply error nahi hai. Imagine, suppose if the scheduled classes are cancelled several times, our Giri will never say the probability will be 1 that I will take the class on Thursday. Never. So for future, whatever you are giving the conclusion need not be 100% true. But smaller the error, you can believe what is going to happen in future.
But sir,
Yes.
how will we quantify the standard error in your case? Like this will
Yes.
approximately be
Yes.
0 as you haven't missed any class.
Yes. That quantification is like this. 5% chance, sir, you will miss the class. Yes, Himani?
So how have you taken 5%?
Can I take 50%?
Like as per the previous classes, we could not say like 5%. I guess 50% is much more than like.
So suppose I say 5% times possibly I will not be taking the class because last week 2 days lectures cancelled by the institute.
Yes, sir.
And the Thursday is coming very near to the New Year day.
Yes, sir.
So the smaller the chance I will cancel the class. It is a prefixed error. That is what I told you because 100% output you can never get in analysis. Standard error you have to tolerate. But the standard error will be small with smaller probability. Is that clear?
We could have taken it to less than 5% as well. No?
Obviously, why not? 1% you can take, 2% you can take, but higher percentage never possible.
Okay, sir.
Past experience tells this. This is called level of significance in testing of hypothesis. So, the answer given by Giri is called null hypothesis. He assumed the probability as 1. Not necessary it will be true. So the probability will be different from 1. Different from 1 means less than 1. So for everywhere, when you analyze certain parameter of your research, you always have 2 hypotheses. Null hypothesis, alternate hypothesis. Null hypothesis and alternate hypothesis. Every time in research, there will be a null hypothesis denoted by H0. There is an alternate hypothesis denoted by H1. A null hypothesis is a statement. It is a claim. It is an assertion on a research parameter. Need not be true. The negation of this statement is called alternate hypothesis. Every research area, whichever you take, biological research area, clinical trial area, now also going on. What do you mean by dry test of the COVID vaccine? Anybody? Nowadays the news are coming by dry test is started in Gujarat. Dry test is going to start in Pune. What does it mean?
Sir, it means a trial run for that process.
Yes, before it implement on the public, sample test, isn't it?
Yes.
Before it goes to the public, we are taking the sample test. Why? Why?
To get to know the success rate.
How much effect is there in the sample analysis? That has to be talked. Then only it can give to the private. That also it coming in the month of March. So every time research is going on, how to implement it, which way to implement it. Directly we cannot give to the marketing. Today's news also was there in ICER. They are along with this COVID, they are finding for pneumonia also. Because elderly persons are, even if recovered from COVID, immediately some are getting pneumonia, danger. So everywhere research objective is for betterment, need not be true. So alteration has to be done only after doing statistical work. So keep in the mind, whichever research you are going to do, there are students in your institute who have to go for research only. इतना fund available है. In case if you develop an attitude of learning research area and analysis, you can be absorbed immediately. We are not getting the students. So simply don't be marks ke piche. Learn concept also. Now also plenty question has come. I have to answer it. How to determine optimum n, sir? What do you mean by error, sir? Himani asked me why it is not less than 5%, sir. So we have to reach a stage where you understood analysis only if I answer such questions. Anyhow, Thursday I'm going to do that. Before that, so every research area has a hypothesis. What is it called? Null hypothesis. What do you mean by null hypothesis? It is an assertion. It is a statement. It is a claim. It is an estimation. It is a prediction for your research objective parameter. Need not be true. Need not be true means its opposite can be true. So, null hypothesis and alternate hypothesis are always together. For example, Vaishali restaurant on Ferguson Road. The manager says 40% of the customers coming to the restaurant are South Indians. What is null hypothesis?
That 40% customers are South Indians.
What is alternate hypothesis?
That it is either less than or more than, or it is not 40.
So how many possibility for answer?
So 3. Less, more, and not equal.
Equal, less than, or greater than. But one of them is true.
Yes, sir.
Searching that is called testing of hypothesis. Tossing of a coin. How many possibility?
2.
2. Are you going to get both at the same time?
No.
But outcome will be one of the two.
Yes, sir.
So either H0 is true or H1 is true in your research area. Find what is true. We call testing of statistical hypothesis. Rather, statistical testing of hypothesis. How many of you understood this? 2 terms. Any question?
Sir, can you please re-explain the alternate hypothesis?
What is the last example I said? Percentage of customers per day visiting to the Vaishali restaurant are South Indians. They born and brought up in South India, settled in Pune and visiting the restaurant. Percentage is 40%. Manager says, I cannot say that because I am not experienced the business. Who is handling the business, he takes the claim. Probability that customer is South Indian visiting the restaurant. That is 0.4. This is null hypothesis, need not be true. So what may be true? What may be true?
So could you please repeat your question?
Yes. Claim is E equal to 0.4 by the manager. Manager says probability of visiting the South Indian is 0.4. This is null hypothesis. What is alternate hypothesis?
Not equal to 0.4.
Not equal to 0.4. P, that is not equal to 0.4. This not equal to 0.4 means P will be less than 0.4 or P will be greater than 0.4. So how many possibility for the P?
3.
How many possibilities for P? P value?
2.
So 3.
3. And one of them is true. Isn't it? One of the 3 will be the truth, na?
Yes, sir.
So search the truth we call statistical testing on this hypothesis. Now clear who asked the question?
Yes, sir, it is clear, sir.
This is what I say, tossing of the coin. Coin example you take, your output will be either H or T. But in one toss, answer is one of the two. Same thing here also. For the coin, I have to toss. And here I have to do statistical analysis to verify what is true. Any question? Searching of the truth in your claim is called statistical testing of hypothesis on parameter. Parameter can be any, maybe arithmetic mean, maybe probability, maybe correlation, maybe regression, maybe standard error, maybe sample size, any. Unless you do testing of hypothesis, you cannot conclude your analysis to the audience. Because if the research is assigned to you, finally you have to explain your work to the audience. You can ask plenty questions just like you ask questions to me. Therefore, the next class onwards, whatever we learn in all the modules, going to come together. Computational work, probability work, cutoff point work, R norm, P norm, Q norm, R binorm, P binorm, Q binorm, D binorm. All these we are going to repeat for testing of hypothesis on parameter. But for one type of hypothesis, all things will not come. You have to choose, is it binomial, is it normal? If it is a correlation test, their binomial and normal will never come. Something else. But the objective is, as per the parameter of your hypothesis, method of analysis also varies. Giri asked me, what happens, sir, if there is a different output, a different observation in the data, or a new variable will be there? So, if the variable increases, accordingly method of analysis also varies. In correlation regression, there are minimum 2 variables. So the method used for one variable will never work for 2 variables. You see, such work is the last work in statistics we have. Such work. So statistical testing of hypothesis is to verify what is true in your claim. And statistical testing of hypothesis will be done through sample. Now to conclude, one example I am giving. Mr. X goes to general checkup every year. Attentive. His age is greater than 40. This always say, after age 40, a general checkup is a must. Doctor takes his ECG graph, found there is a change compared to earlier graph. Doctor recommend a test before final decision. Yes, Giri. Giri.
Yes, sir.
After recommending a test for Mr. X, where Mr. X goes?
So let me read the question again. Okay, so yeah, he'll go to a different he might consult a different ECG.
Where he will go for that? Not ECG. Doctor recommend him a test before final decision. Say blood test. Where he goes?
Lab.
Lab. Which lab?
Pathology.
Computer lab?
Sorry, sir. Blood.
What is the correct name of the lab? What is the correct name of the lab?
Sir, pathological lab. sir.
Pathological lab. What nurse does?
Takes his blood sample, sir.
Blood sample. Why she didn't take the complete blood from the body? Why she cannot take the complete blood from the body?
She needs a small sample to analyze.
There's nothing to analyze. So she takes only sample blood. So analysis is done on what?
Sampling, sir.
Ah,
Sample collection, sir.
yes. Sample collection, sample blood is analyzed. So the report you are getting in number form.
Yes, sir.
And this report is given to whom?
Doctor.
And doctor decide the treatment after seeing the report. Yes?
sir.
Yes, sir.
So, what sample test says, doctor will believe for the entire body. This is testing of hypothesis. How many if you follow this example? Ask questions on this example.
Sir, but there could be some errors also in the
Yeah, possible. Technical errors are there happening in pathology lab. But without the sample blood analysis, how the doctor can take decision? He can cut the body and check inside. Tell me. So, by doctor's experience, he may be having the pathology lab who does the full justice. So, he may recommend you to go there. But the probability of making error will be small. Am I right?
Yes, sir.
Kitna technology improved nowadays, Wi-Fi everybody has. Still there will be problem for working with computers. So error will be inevitable everywhere. We have to develop tools to minimize the error to reach our objective. That is what this tells example. The null hypothesis that he was perfect last time, so possibly he will be same condition this time. Because every year he go for general checkup. So alternate hypothesis, yes, possibly not. So experiment. What is it? Take the ECG graph first. One of them. And ECG graph, if it is same as the earlier ECG graph, one factor is removed. Go for the other factor, sugar level. Cholesterol level, body weight, pulse rate. So in the ECG graph it is found there is a bad change. Doctor recommend the procedure, sample blood test. So the word used was sample blood because that is the only way possible. Go to the pathology lab, analyze it and get the report on paper by number form. On the paper there is no blood, numbers. And looking the numbers, doctor decide about the treatment.
So,
yes.
Taking the same example, how will we choose p-value for this? Like for the null and the alternate hypothesis?
Yes. Another question also I got. Another question also I got. I will tell you p-value. I will tell you p-value, t-value, z-value. Plenty values are there in testing of hypothesis. I will let you know. But this concluding part today, we should define testing of hypothesis. Three things I have said. Everywhere there is a null hypothesis and its negation is alternate hypothesis. Truth will be either in null hypothesis or in alternate hypothesis. Through sample, find out the truth is called statistical testing of hypothesis. In the next class, I have to explain several other terms. Enough for today. Enough for today. Let me ask the questions.
Sir, I have one question before that. Like in this question that we just took. So basically, the test was the ECG report itself. Why do we need blood sample? Because there would be various components.
I simply said it. ECG graph ka one way. It's a cholesterol level. Dekh lo. He found out body weight is increased.
If someone is healthy, what we were assuming is he got ECG done. So if it was normal, he is healthy. If it is not, he is unhealthy. So that is our null and alternative. Why do we need to go for the blood test? And
That is what I say. After, see, biologically what happened, irrespective of
वो तो testing
gender-
वाला part हुआ ना. What I'm trying to ask is that is the testing part of the hypothesis. Like the hypothesis was if the person is healthy or not. Based on ECG, we said like if he is healthy, so normal ECG, and if he is unhealthy, abnormal ECG.
ECG is only for the heart rate, na?
So like then there is a variation. No.
There may be other parameters also to be checked. One of the parameters you take, he found out compared to last year, body weight now is increased. And he asked about his diet. He said that I have changed my diet. Okay, so once the diet is changed, it get affected to the body after age 40, definitely. And Mr. X is not nearly 40, maybe around 67, 70. So doctor says, let us check your cholesterol level. Because he says that I am tired many of the time when I walk. Okay, so unless you do the testing on different parameters of the body, how can you verify why he is so tired when he walks? So this is just a counter example I gave you, that's all. If I take a ECG graph, I can verify whether it is normal or not compared to the other graph.
Sir, in your own example, what would you state a null hypothesis?
In my null hypothesis that he is better as earlier he was. And the alternate hypothesis says that no.
Okay, got it, sir.
Anybody else? Anybody else?
Sir, I have a doubt, sir.
Ask.
Sir, it is an off-topic doubt actually. Sir, in my assignment, I used equals to sign in case of, sir.
You have gone to assignment now. Okay.
Yes, sir. Sir, I have used the equals to sign in case of, sir.
No problem. No problem.
Okay, sir.
No
Okay,
problem.
sir, thank you.
Any other question? Very few students are asking questions. That means everybody is understood or not. Simran, Simran,
Yes, sir.
do you follow?
Yes, sir.
What is hypothesis testing? Can you explain in brief?
Sure, sir.
Yes.
So, sir, in our day-to-day life also, we can see examples for hypothesis testing. So here hypothesis testing is basically that we select, like, sir, we have one null hypothesis and an alternative hypothesis, where the null hypothesis tells us about the original. Sorry, sir.
Okay, can you give an example?
Hello?
Yes, Simran, can you give an example?
Yes, sir. So, like, for example, right now, the example that you took about the person who got the ECG test.
Yes.
So here also we could see that what was the probability that he should go for another test or not,
Yes.
for a blood test that could depict his sugar levels or other tests also.
Okay.
Sir, a basic example could be of, Cherry speaking here, of the COVID test that is happening nowadays.
Correct.
And the chances of error, like if the person is positive and still the report comes negative,
Yes.
so there's a type 1 and type 2 error also. In
Yes.
this, we can see it perfectly clear how it happens.
Yes. Such part I will be coming on Thursday class. Error of analysis. Type 1 error, type 2 error. So any other questions? So I told you are going to submit the modified assignment. You are preparing for class test up to binomial and normal distribution, that is module 4. And by today or tomorrow, module 4 ka algorithms I will be mailing through Srikanth sir. Any other questions you have?
No, sir.
Okay.
Sir, related to this exam, I have a question. Like when you say you would be giving MCQs, would you be checking theoretical aspect of it or
Little bit theoretical aspect also I will add.
little bit, which means
Yeah,
that
yeah,
you expect us
Yeah,
to
yeah, yeah,
basically
yeah. It is not
Sir, listen
necessarily
now.
completely numerical,
Yeah, so it would be numerical and based on
as well as definition oriented theoretical.
Okay. So assumptions and numericals basically. Okay, sir.
Verbally also I can ask questions. Na? Given a situation and identify what type of variable it is, what type of distribution can be used. Concept has to get clear.
Another question, sir. Quick question. Like it would be similar, like how we gave our these UTs. So it would be a 1 hour exam, right?
Yeah.
And how many questions do you expect us to solve?
Mostly I will be adding 20 questions. Each
The 20
carry 1 mark.
questions.
Yeah.
Okay.
Each carry 1
Sir,
mark.
would be short kind of questions, right? Like it will not require a lot of code to be written. Like
No, you will be comfortable to answer within an hour.
okay, sir. Then it's fine.
I will not put anybody in trouble. I want
you,
to
sir.
know how much they understood on the test. That's all.
So will it be, you'll be asking a numerical question or
Yeah.
will be asking something to write on R?
No.
No R.
Right, not right on R.
Okay, thanks.
Okay then. Really the class was good today. Much better than earlier classes. Because of the question answer session, many of you have understood their doubts. So same spirit you have to show when I introduce the testing of hypothesis on Thursday class. Everybody has to know the difference between normal distribution and standard normal distribution, meaning of cutoff point, etc., etc. You should know the meaning of probability. You should know the meaning of standard error. All will come together on Thursday's class. Okay.
Thank you, sir.
Goodbye. Have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.